today we're talking about Pythagorean theorem and its converse, all right? And so hopefully by the end of this you'll be able to use the Pythagorean theorem to find the length of a side of a right triangle, which we've been doing, and how to use the converse to determine if it's not a right triangle, is it acute or obtuse. So of course you start off with your basic Pythagorean theorem, which is basically says the square of the hypotenuse is equal to the sum of the squares of the other two sides. That's what we know to be our classic a squared plus b squared equals c squared. Okay, we know that. And we know that the longest side is our hypotenuse. And it really doesn't matter what is a or b. It's just basically they can't be the hypotenuse. Now, a Pythagorean triple is the set of three positive integers, a, b, and c, that satisfy the equation for the Pythagorean theorem. Now, an integer is basically a whole number that cannot be, it can't be a fraction, it can't be a square root, it can't be a decimal, it can't be a negative number, it has to be positive whole number. So an example of Pythagorean triple would be 3, 4, and 5. So 3, 4, and 5, or any multiple of 3, 4, 5, so like 9, 12, and 15 are an example of Pythagorean triple. Okay, because think about it, 3 squared plus 4 squared. Okay, you know that will represent a and b because the longest side is 5, and that would have to be your hypotenuse. So if you set it up like this, you would see that you'll have 9 plus 16 equals 25. Okay, that is indeed a Pythagorean triple because yes, 3 squared plus 4 squared is indeed what 5 squared is. Okay, same thing works with the next one of 5, 12, and 13. Okay, well 5 squared plus 12 squared, trying to see if that equals 13 squared. All right, well 5 squared is 25, 12 squared is 144, and I'm trying to see if that equals what 13 squared is, which it does. It equals 169. So again, a Pythagorean triple has to be a positive whole number. Don't worry about this proof just yet. We have one more section to cover before we actually do this proof. So just skip it. Now the converse of the Pythagorean theorem is basically what helps determine if we have something other than a right triangle. Of course, the first one talks about our good old classic Pythagorean theorem that says a squared plus b squared equals c squared. But the next two theorems, Theorem 9.6 and Theorem 9.7, tells us if we have an acute triangle or an obtuse triangle. And actually to figure that out is that if our hypotenuse, or not our hypotenuse, if our longest side squared is less than a squared plus b squared, then we know it's going to be acute. Okay? So if the longest side, the c squared, is less than a squared plus b squared, then you know it's going to be acute. And if it's obtuse, is if c squared is greater than whatever you get when you do a squared plus b squared. So we're going to look at an example of that actual particular situation. So to determine if the following triangles are right, acute, or obtuse, we still need to do good old classic Pythagorean theorem. And we have to figure out what our c is going to be. Okay? Our c is our longest side, so the square root of 113 is our c. So when I set it up, it's going to be the square root of 113 squared and then a squared plus 7 squared. All right? Well, when I square square root, these actually cancel out. So I'm going to be left with 113, then 64 plus 49. And when I add them, I do indeed get 113. So they're equal. And because they're equal, I know I have a right triangle because it actually satisfies the Pythagorean theorem. Now over here for the next one, my longest side is 86, so that's going to be my c. So I do 86 squared and then 77 squared plus 38 squared. Now yeah, you may need your calculator here because these are pretty big numbers. But 86 squared is 7396, and then 77 squared plus 38 squared is 7373. Now if I look, my c squared is greater than my a squared plus b squared. And because it's greater, that means this is an obtuse triangle. So what I want you to do is I want you to pause this video and try 5 and 6. Pause this video. Alright, so hopefully you set it up like this. Okay? Your longest side was 37.5, so when you square it, you should have got 1406.25. And then when you square 36.5 and 10.5 and add them together, you got 1442.5. If you notice, the a squared plus b squared is greater than c squared, or c squared is less than a squared plus b squared. In that case, you know you have an acute triangle. Over here, you have 24 squared, which is 576. And then 8 squared plus 18 squared is 388. C squared is greater, so this should have been obtuse. Over here, this is good old classic Pythagorean theorem, okay? Now we don't have to do all these problems, we're just going to do a couple, okay? Here, x is my hypotenuse. So square root of 5 squared plus the square root of 8 squared equals c squared. Again, when I square a square root, the square root goes away and I'm just left with the number underneath. So this is going to be 8 plus 5 equals x squared. 13 equals x squared. Take the square root. And from here, we're actually not going to type into our calculator to get a decimal. We're actually going to simplify our radicals. Simplify. That means break it down. See if I can simplify this anymore. To do this, I look for my prime factors. Two numbers that multiply to give me 13 are 1 and 13. I can't go any further than that. So because this can't be simplified any nicer, my answer is the square root of 13. Down here, this is a triangle attached to a rectangle. If a rectangle, remember, opposite sides are equal, so this side is 10. So I'm going to set it up. X squared plus 10 squared equals 12 squared. Remember, 12 is my longest side. It's across from my 90-degree angle in a right triangle. And so that's why I know that C is 12. Simple math, work it out. And now I'm at the point, okay, I have to simplify 44. Two numbers that give me 44 are 2 and 11. 2 and 22. Now 2 is prime. I can't break this down anymore.
Good afternoon, everyone.
But 22.
Mr.
I can break down 22 to be 2 and 11. Now, I don't know how you learn how to simplify radicals, but the way I teach my students is that once you break it down into its prime factors, wherever there's a pair of prime numbers, like in this case there are a pair of 2's, you pull that pair out, and whatever doesn't have the pair stays on the inside. So x equals 2 root 11. Let's look at number 11, okay? It's a square, so all the sides are equal. So we're going to have x squared plus x squared equals 5 square root of 2 squared. X squared and x squared make 2x squared. When I actually type this into my calculator, I should get 50 because technically this is basically saying 5 squared and then square root of 2 squared. Well, 5 squared is 25, the square root of 2 squared is 2, and I multiply them together, and then that's how I get 50. Divide both sides by 2, x squared equals 25, take the square root, and x equals 5. Now the last part says, tell whether they form a Pythagorean triple. Well, remember, Pythagorean triple is 3 sides of the triangle that are all whole positive numbers. 7 is not a Pythagorean triple because you have the square root of 5 and the square root of 8, the square root of 13, all those have roots in it. You cannot have a Pythagorean triple if you have roots. Number 10, this is not a Pythagorean triple because, again, one of our sides was 2 root 11. And over here, for number 11, the hypotenuse had a 5 square root of 2. So no, this is not a Pythagorean triple either. Okay? So that's how Pythagorean triples work. Over here, we have to figure out if this is a right triangle. The same way using the converse. I need to see if c squared is either equal to, greater than, or less than a squared plus b squared. Our longest side is 75. So that means 72 squared has to be added to 21 squared. And if I check, 75 squared is 5625. And then 72 squared plus 21 squared is 5625. So because they're equal, yes, this is a right triangle. And on top of that, it's a Pythagorean triple because they're whole numbers. Okay? Last ones. I want to decide if these are triangles, and if they are, what kind of a triangle they are. Well, if you recall back from chapter 5, the triangle inequality theorem, it said that if you add two sides, it should be greater than the third. 8 plus 12 is greater than 18. 12 plus 18 is greater than 8. 18 plus 8 is greater than 12. So yes, this is a triangle. So yes, it's a triangle. What type? Do the converse of Pythagorean theorem. 18 squared is 324. 8 squared plus 12 squared is 208. Because 324 is greater than 208, this is an obtuse triangle. For this one, and you're probably like, well, I don't know what the square root of 15 is. I don't know if it's going to be bigger or less than whatever. Well, type it into your calculator. The square root of 15 is about 3.87, and 5 square root of 2 is 7.07. And so if I add 6 and 3.87, it's going to be greater than 7.07. If I add 3.87 and 7.07, it's greater than 6, and so on and so forth. So yes, this is a triangle. My longest side is 5 square root of 2, so that's going to go on the side by itself. And then 6 squared plus the square root of 15 squared is going to go on the right. Well, I just did 5 squared root of 2 squared on the other page, so that's 50. And over here, 6 squared plus the square root of 15 squared is 51. C squared is less than A squared plus B squared, so this is acute. And the last one we're going to do before I end this video, and by all means you can do any of the other problems on your own time, but these are the only ones I'm going to do with you, is this last one. Okay? Check to see if it's a triangle. 7 plus 11. That's not greater than 20. So instead of sitting here and wasting my time, this is not a triangle, so I cannot figure out if it's acute, obtuse, or right. Hopefully this was able to help you guys, for those of you guys who weren't here in class today, or if you needed some extra practice and extra help, please bring any of your questions or anything like that to class the next time I see you.